Does it mean that I cannot modify this file inside the container? No. I can still modify this file, but before I save the modified file, Docker automatically creates a copy of the file in the read-write layer, and I will then be modifying a different version of the file in the read-write layer. All future modifications will be done on this copy of the file in the read-write layer. This is called copy-on-write mechanism. The image layer being read-only just means that the files in these layers will not be modified in the image itself. So the image will remain the same all the time until you rebuild the image using the docker build command. What happens when we get rid of the container? All of the data that was stored in the container layer also gets deleted. The change we made to the app.py and the new temp file we created will also get removed. So what if we wish to persist this data? For example, if we were working with a database and we would like to preserve the data created by the container, we could add a persistent volume to the container. To do this, first create a volume using the docker volume create command. So when I run the docker volume create data_volume command, it creates a folder called data_volume under the var lib docker volumes directory. Then, when I run the Docker container using the docker run command, I could mount this volume inside the Docker container's read-write layer using the -v option like this. So I would do a docker run -v, then specify my newly created volume name followed by a colon and the location inside my container, which is the default location where MySQL stores data, and that is var lib MySQL, and then the image name MySQL. This will create a new container and mount the data volume we created into var lib MySQL folder inside the container. So all data written by the database is in fact stored on the volume created on the Docker host. Even if the container is destroyed, the data is still active. Now what if you didn't run the docker volume create command to create the volume before the docker run command? For example, if I run the docker run command to create a new instance of MySQL container with the volume data_volume2, which I have not created yet, Docker will automatically create a volume named data_volume2 and mount it to the container. You should be able to see all these volumes if you list the contents of the var lib docker volumes folder. This is called volume mounting, as we are mounting a volume created by Docker under the var lib docker volumes folder. But what if we had our data already at another location? For example, let's say we have some external storage on the Docker host at /data, and we would like to store database data on that volume and not in the default var lib docker volumes folder. In that case, we would run a container using the command docker run -v, but in this case, we will provide the complete path to the folder we would like to mount, that is /data/MySQL. And so it will create a container and mount the folder to the container. This is called bind mounting. So there are two types of mounts, a volume mounting and a bind mount. Volume mount mounts a volume from the volumes directory, and bind mount mounts a directory from any location on the Docker host. One final point to note before I let you go. Using the -v is an old style. The new way is to use -mount option. The --mount is the preferred way as it is more verbose, so you have to specify each parameter in a key equals value format. For example, the previous command can be written with the -mount option as this, using the type, source, and target options. The type, in this case, is bind, the source is the location on my host, and target is the location on my container. So who is responsible for doing all of these operations? Maintaining the layered architecture, creating a writable layer, moving files across layers to enable copy and write, etc. It's the storage drivers. So Docker uses storage drivers to enable layered architecture. Some of the common storage drivers are AUFS, BTRFS, ZFS, device mapper, overlay, and overlay 2. The selection of the storage driver depends on the underlying OS being used. For example, with Ubuntu, the default storage driver is AUFS, whereas this storage driver is not available on other operating systems like Fedora or CentOS. In that case, device mapper may be a better option. Docker will choose the best storage driver available automatically based on the operating system. The different storage drivers also provide different performance and stability characteristics. So you may want to choose one that fits the needs of your application and your organization. If you would like to read more on any of these storage drivers, please refer to the links in the attached documentation. For now, that is all from the Docker architecture concepts.